Let's start. All right. So today we'll be covering the immune system. Um, there are first we should probably talk about note taking. So preferably most of you will have a pencil or pen, some paper. Uh, your brain probably should be there, and you obviously need me so I can actually teach you. Now, if you want to, I'm not going to give you all of the information on the slides. That's a lot of things to write down. So instead, I'm going to be giving you analogies and the most basic terms, and then I'll explain all of them by speaking. And now, if you want to take notes based on what I'm saying, I'll tell you like what the most important things are, and then you can based on what I say is important, you can take down whatever notes you feel like you might need. All right. So there are actually two parts of the immune system, the innate immune system and the adaptive immune system. These both focus on different things. The innate immune system is like the first response. It's everything that happens outside on like your skin and then just into your skin. And so that will be things like wounds, so injuries, pathogens, just random viruses that happen or bacteria that happen to be around your skin or under it, and foreign objects such as splinters. Whereas the adaptive immune system, that'll focus mostly on the viruses and bacteria themselves, and then also cancer cells or other changed body cells. Now, we can call the innate immune system kind of border patrol. The patrol will be helpful in a bit. And so the innate immune system consists of the skin, mucous membranes, immune system cells, and proteins. Now, the skin is like your first response. It's the wall that keeps all of the bad things away from the inside of your body. And so this is wood, so random wood splinters again. So those obviously they hurt, but your skin still protects you from them. And other things such as like sandpaper, which can damage your skin, but it doesn't necessarily do that just because skin is that important. Mucous membranes are all over your body, like in your nose. They're what causes boogers, and then also in your stomach, and that's what keeps bacteria and viruses from infecting your food sources. And now you also need the proteins because obviously everything is founded on proteins. And so all of your cells are going to need proteins to do everything that they do. Now, patrol is actually an acronym. And so you can, first is skin, and P for physical, because the skin stops physical things from entering your body. And so we're going to introduce some players in our skin. So first we have our three skin cells, the professional walls. These guys are the first barrier to all of the bad things or the harmful things that happen outside of your body. And that something like that would be this wood splinter right here who wants to get into your body and wreak some havoc. Now this little kid here, this is a platelet. And the reason why he's such a little kid is because platelets are tiny. They're not much bigger than blood cells, so they're not going to be like super big, influential things. However, they are very important, as you'll see. When the splinter breaks that skin, when it breaks into those skin cells and causes some chaos, the platelet is going to be called into action, and he's going to come over to the skin and he's going to go do something about it, because we don't want that splinter in our skin and we don't want our blood to be flowing out of that wound. And so when we take out that splinter, or if we keep it in for some reason, that platelet will go and bind all of these skin cells back together by using blood and other proteins. And by doing this, they're going to take that, they're going to kind of like reaching out and grabbing onto the cells. They're just going to hang on tight and then pull everything back together until that skin can heal. There's another part of border patrol is the mucous membranes, and we can memorize this by the TR in patrol. TR for trap, because what they do is they trap different tiny little substances such as dust. The mucous membrane consists of epithelial cells and lamina propria. These are the two outermost cells that are most influential in making sure that dust does not get into your body and harm your interiors. And what the epithelial cell is this guy is going to make the slime that that grabs onto all of this dust. He is the main source of basically making sure that everything is contained into one place so that you can get rid of it immediately. Now the lamina propria, this is like a foundation. It's behind the epithelial cells. It gives the epithelial cells all of the resources, all of the proteins it needs to create the slime substance in order to trap this dust. And so it's kind of like a concrete truck. It brings all of the concrete, all of the cement over to our epithelial cell so that it can create concrete. Now, when this dust gets in through our bodies, the epithelial cells finds out and it starts releasing all of this cement. And this is going to bind to the small particles and it traps them, and they become or like boogers. So this is very easy to get rid of because this is a lot bigger than a small particle that can easily get lodged in your body. Now, the last part of the innate immune system is actually technically also a part of the adaptive immune system. So this part, what it wants to do is it wants to get rid of all of the pathogens that are coming into your body. And so this, the first response is consisted of the neutrophil, the macrophage, and the cytokine. Now, the neutrophil is a smallish cell whose purpose is essentially just to kill pathogens. And so he's going to be all over your body. He's in your bloodstreams. He's all over. And the macrophage, who, although he also fights, his main purpose in the innate immune system is to call other cells to come and fight. And the cytokine, which is his microphone, it's his way of, it's the chemical that he screams out to make sure that everything gets here. Now, let's say there's a virus and a bacteria in influx from the splinter that just got into your skin. Now, immediately, the neutrophil is going to see those viruses and those bacteria, and it's going to start attacking them. And the macrophage here, it's going to start sending the cytokine to call out all of the different neutrophils and NK cells, or natural killer cells. And the NK cell you can think of as like an assassin. He's pretty much alone, and he goes around killing anything that he can find. What the macrophage also calls is the dendritic cell, and though this guy can also fight, his main purpose is to tell the adaptive system to start working. Now, once they see these invaders, the virus and the bacteria, they're going to, obviously, all of them are going to start attacking. So the neutrophil is going to grab this bacteria right here. It's going to smash it to death. And then remember that all those recruiters back here, these guys, they're going to come over and they're also going to come fight because their macrophage has done its job. And since it's done its job, it can also fight now too. At the end of the day, hopefully they win and everything's back to normal. Are there any questions on the innate immune system currently? Yes, Lily. So the immune system is violent precisely because its purpose is to kill things. You want to get rid of all of the bad guys that are trying to enter your body so that you can be healthy. Exactly, Alan. Lily, what was your question? You can unmute. I guess so the reason why I can't ask the bad guys to get out is because these bad guys are like very bad guys. These are terrorist bad guys. All all I wanted to do is to come into your body and then get rid of everything. And so, yes, exactly. The bad guys didn't listen. Yes, that's the purpose of the immune system. It's to murder all the terrorists. Are there any other questions? That's pretty much it. Is the innate
I
that's the
have a
innate immune.
question.
Oh, go on.
The virus and the bacteria is from the splinter, right?
Yes. So, or other things that might enter your body. This could be just from the air you're breathing. And so then what would happen is the mucous membranes would trap those, and with the concrete, hold on, I can't,
Okay.
with the concrete here. So that's what the adaptive immune system does. So since if there are any other questions, if there aren't any other questions on the innate immune system, we can go on to the adaptive immune system. All right, perfect. So first, we're going to introduce these guys as the special forces. These are the guys who come in after everything has happened, and also to keep fighting after everything has happened. So what the people who are in these are the SWAT team. These are the antigen presenting cells, the APCs, and then the memory cells. And to answer George's question, the memory cells are the reason why we can memorize these viruses. And so we're going to start with the APCs. This is from before the dendritic cell, which is the siren that calls the adaptive cell into action. The macrophage, which is the guy who calls all the other cells to come and help, and the B cell, which is a vital, basically a killer cell. But for now, since this is still the APC, it's going to be a printer. And what they're going to do is they're going to drag all of these parts of these dead bodies, the dead viruses, the dead bacteria, and it's going to bring them to a lymph node. And what they can do then is they can start printing 1 billion flyers. And what these flyers will do is they'll attach to other remnants. They'll attach to the other viruses and bacteria of the same kind. These flyers, they're kind of like homing missiles, except they don't kill anything. They just attach to it. However, sometimes they can kill things, but that's a very specialized antibody. So their main purpose is to mark out all of these bacteria. Yes, Levy.
What happens after the virus germs die? Do they like get buried in a funeral cemetery?
What happens is yes, they get eaten. So yes, exactly, Ethan. My gosh, you should be the teacher. So the macrophages, after they've eaten them, they break them apart using specialized proteins. They use specialized proteins to break apart the dead bacteria or viruses. Actually, what happens is they're eaten first and then murdered. So switch that around. Exactly. So so the macrophages, they have like long tentacle arms that reach out and then they surround the bacteria, and then they break apart and then become part of the macrophage. And then inside the macrophage, it uses enzymes to break apart all of the different proteins inside the bacteria and the virus, and then it uses those as sources of basically food. Our B cell here, it's gonna print all of these flyers, which are going to go attach onto onto the viruses and the bacteria. And the reason why it can do this is because they have proteins that are specially shaped. And so let's say that you've got like a square-shaped protein on the bacteria. So it's got like let's pretend this bacteria here has like a square on it, on the bottom of it. And this flyer, it has like a square-shaped hole. And so whenever that flyer encounters this virus, that hole fits perfectly. And so it's going to attach to it. And so that's how the flyer sticks to the virus. Now, since the flyer is stuck onto the virus, the T cells can come into action. And so these guys, that's the flyer's job. So the flyers tell everything that this guy needs to die. So now onto the T cells, which are the chief executives. These are the guys that make sure that everything is going normally. And so first we've got this helper T cell in the red Adidas. This guy just manages things and then supports. Oh, before the flyers. So before the flyers, you're gonna go back all the way back to DNA. So before the flyers, basically it's anything that doesn't. No, Ethan, not yet. I'll explain it first, and then if you want to add something, you can add something. All right. So, to put it simply, they see anything they see anything that doesn't belong. Oh, oops. They see anything that doesn't belong. So this virus and this bacteria, this kind of looks weird to the neutrophils, and so they'll kill it, and then the macrophage will eat one of these, and then print out, and then bring like the dead body over to the lymph node, where they can memorize this virus, so that next time they see it, it'll be easier to kill it. Does that make sense? Okay. Okay. What do you want to add, Ethan? Yes. And Ethan, before you continue explaining, I'm not gonna let you continue until you turn on your camera. Why not? Why not? We gotta see you. All right.
If you turn on your camera, I'll pay you $100.
No, we're not bribing people here. We're not gonna bribe people. We just want Ethan to
Yeah,
turn
turn
on
on
his
your
camera so he can be a proper teacher, you know?
Yeah.
No? Okay, then I'll explain it. All right. What? All right, Ethan. Then you Okay. Well, to elaborate on what Ethan said, because he obviously thinks he's very smart, and I know he's very smart. But when these bad guys come in, so the virus and the bacteria, they're obviously going to do some damage. They're going to do some damage before we're able to do anything. And so, like wrong way. Wrong way. All right. So when the splinter comes in, those bacteria have already encountered the skin. And so the skin is going to release proteins that tell the macrophages that this is not a bad guy. And then since the viruses don't have this, the neutrophils will see, oh, this is not one of our friends, and so we're going to kill it. Back to the flyers. Oh, we're done with the flyers. All right. So the helper T cell basically manages all of the minor things, such as making sure that everything is dying. This is like the McDonald's general manager that the Karen always wants to speak to. He's like a super buff. He's gonna make everything work harder and then also faster. And then we've also got the cytotoxic T cell. And this guy, he's like he's like the secret agent. He's the guy in the building that makes sure nobody is like being corrupt. And so he's got a gun and he kills all of the cancer cells. So the cancer cells are basically like corrupt normal cells. They intake more food than they need to, and that's actually how these cytotoxic T cells recognize them. No? What is happening? Ethan, you don't have to turn on your camera. No,
If you're
no.
going, if you guys are going to chat, can you like do it privately? It's like we keep getting notifications and it's so annoying.
I would turn off chat, but all right. Let's continue. All right, so cancer cells, the reason why these cytotoxic T cells can recognize cancer cells is because they can see that they're money laundering. So these cancer cells are taking more money than they need to, and so the T cells can see that. And what they're going to do is they're going to assassinate them before they can keep spreading. And then finally we've got the regulatory T cell. He's the CEO. He's the big boss. He's the one that starts the immune system, and he's the one that ends it. Yes, he's Elon Musk. He's the richest guy in the cell, in the body. So the reason why cancer cells proliferate, that's because Jeff Bezos is not the richest guy. The reason why cancer cells end up proliferating is because the T cells aren't good enough to recognize that there's money laundering happening under their noses. So this would be kind of like if the cancer cells were disguising themselves as normal cells. And so they look like they're just taking their normal amount of money, but actually they're not. And so it still isn't particularly known why cancer cells are able to proliferate that fast, but that is essentially what the reason why cancer is still a thing. It's just because our bodies are not perfect, and so we're not able to detect everything. This is also how you get severely sick. It's if a viral infection gets out of hand, and then you can also die because of it. And it's also why cancer is it's not just like caused by external sources. You can get cancer because your genes allow you to get cancer. And so like if your mom was susceptible to lung cancer, you probably are too because you inherited her genes. And those genes are what make cytotoxic T cells. And so if your mom is making one type of cytotoxic T cell, you're making it too. And so they're both going to be kind of bad at recognizing, like, let's say a lung cell being a bit naughty. And now we're on to our actual fighters. So these B cells, this is like the James Bond. These guys go around. Yes, like the John Wick, both James Bond and John Wick. Both of those guys are B cells. And so they're like the guys who 1v50 the entire terrorist force. And their gun, that is the antibody. It's the flyer from before, but oh my gosh, what is happening? But instead, this flyer is actually being a gun now. And so it's going to allow the B cell to kill all of these viruses. Yes, he shoots the flyers, and these flyers allow the B cell to kill them. And so the flyers, they're also coated in like mustard gas. And so whenever these viruses get stuck on a flyer, they also get incapacitated because they can't really do anything anymore. And any questions? No questions. Are you curious about anything else? No, you're not curious about how some of these things work. Curious George is curious. Let's go back to I'm not going to talk about the boogers.
Oh yeah. I'm sorry.
Go on.
Why is it like the boogers? Like, why is it the same texture?
What do you mean by that? Oh, where does our body get the stuff?
Yeah.
So this is like in the food we eat. So our food has a lot of proteins and carbohydrates in them. And so these carbohydrates and proteins are the building blocks of all of basically all of the stuff in our body. And so proteins are made up of amino acids. And these are like let's call the protein like a Lego build, and the amino acid is the Lego. There are 21 different Legos that you can build with, and these are what we eat boogers. Well, we eat parts of boogers. So yes, I guess you can say we eat boogers. It is kind of disgusting, but it's turned into a booger by your body. You don't actually eat it as a booger. Yeah, it is gross, right? You're gonna throw up. Don't throw up. Please don't throw up. Wow. Okay. I even asked you nicely. Yeah, we only have 21 types of Legos. We have more Legos than that, but there are only 21 types of Legos. And so we've got like the 1x2x3, got the 2x2x3, so on and so forth. Um, let's see. Oh yeah. So back to what happens if none of this works. So first let's talk about the platelets. So if your platelets don't work, if there's a deformity that makes them not able to become like this little construction worker guy, but rather like a head, an arm, a body, and like no hat and no legs, then this doesn't happen. Oh my gosh, the platelets are basically useless. They can't hold on to these walls because they don't have any arms. And so these walls are just going to fall apart. And this splinter here is, yeah, and then the splinter is gonna do like a lot of damage. And so this is then you can't clot, your blood doesn't clot, and so you can't make scabs, and so you'll just bleed forever. This is actually called what is it? Sorry. Oh man, I should put. It's called hypo. Let me get my notes. Um. Oh my gosh. So this is. Oh my gosh, I can't find it. Um, let's see. Oh gosh. No, it's not in my notes. All right. So if you can't blood clot, then again, you'll bleed forever. And so this is a bad thing because even if you get like a tiny, tiny cut in, let's say your finger, you're going to die because you can't stop that blood from you can't stop the blood from just flowing out of your body. So you die from blood loss pretty much. And if you're not able to create mucus, all of this dust, it can clog your arteries, your veins. It can get into your bloodstream, and obviously you don't want to do that because again, you die from not enough blood. What it also does is if it gets into your lungs, then you can't breathe properly. This is what leads to like yeah, it's a bad thing. This is hypothermia is an example of something getting into your lungs and stopping you from breathing. That's like water. So if there's too much water in your lungs, you can't breathe, and so you drown on land. And if your immune system doesn't work, so your neutrophils, your macrophages, your cytokines, if you can't synthesize hypothermia, so yes, it can cause from colds. So it weakens your immune system, and so if you are cold, then you're a lot more susceptible to bacteria, and so you can die from infection as well. Yeah. So let's see. So if your immune system here, if your cells don't work, then you can't, well, you just can't fight. And so people who have these kinds of disorders end up not being able to survive for very long. There's actually the bubble boy is an example of a person without an immune system, actually. So he had to stay in a bubble for pretty much his entire life because he couldn't have external antigens from getting into his body, because otherwise he would have pretty much died immediately. So people like that can still survive though, because if they have, let's say like a working macrophage, then they can still detect antigens based on like these flyers. And so they can still detect like the things that they've found already. And so they can still kill like random viruses. Any more questions? No questions. I don't really want to give you scientific names for all of these because they're very long and not very helpful. This is very helpful. You want to know all of these? Does everybody else want to know scientific names? No, I don't think. Yes. So let's put this to a majority vote. Raise your hand if you want to learn about scientific names. 7 people. I think that's enough. All right. Oh boy. All right. 7 out of 30. No, it's not a majority, but since we already have a lot of people who want to learn about it, we can learn about it anyways. All right. So let's see. What should we start with? And I can't access my notes. Oh gosh. All right. So platelet is just a nickname. I think it's just because biologists are lazy. Like biologists just don't like having long names, so they named it a platelet instead because it looks like a plate. It's like a little flat disc. The actual name is a thrombocyte. I don't know why, but it's called a thrombocyte. CYTE, not like vision site. It's like cytokine site. Yeah. As for thrombocyte, yes, thrombocyte. So let's see. I'm gonna stop sharing real quick so I can get my notes out because I do not have all these memorized. Okay, so if you so I mentioned a separate another backbone to the mucous system. So this is like the lamina propria and the epithelium cells. Both of these have another backbone, and so this is the muscularis mucosae. And so what this does is it basically allows the mucous system to move. And so it's just a series of smooth muscles that moves around all of these epithelial cells so that they can attack all of the dust particles. Yeah, immunology. Let's see. Let's see. What other scientific names do you want to know? Nothing. No questions? Ethan's scientific name?
Do blood cells have a scientific name?
So blood cells do have a scientific name. So most people just call them blood cells because that's the easiest way to do them. But you can call them erythrocytes. So I don't know why you would call them erythrocytes though, because blood cell is perfectly fine. It's a short name that isn't hard to remember. And then yes, erythrocytes, and then okay, and then the white blood cells are called leukocytes, and so these are like the B cells and T cells, and the macrophages. That's pretty much it for the immune system. There isn't like a ton of information. There isn't a ton of like things you need to know about the immune system. Those are the most basics. It is very complicated, but this is the most basic that you need to know. Basophils, we can go on to those. I do not have a PowerPoint prepared for those though. Okay, so basophils are a type of white blood cell. One of three types actually. So what the basophils do is they're kind of so the basophils they are essentially just another type of like neutrophil. No, I'm not sharing screen because this is not part of the PowerPoint. So they're just another type of neutrophil that goes around just killing foreign objects. And so anything that it doesn't recognize, it'll pretty much murder. And so they release two different types of enzymes when they're trying to fight these external objects, and those are histamines and heparins. And what histamines do is they increase the size of your bloodstream, and so that more immune response can happen, allows more blood flow and more proteins to enter the site of like infection. And so histamines are the reason why you can have like a super fast response. And so that causes like redness in your skin. And so because there's so much blood just located around that area. So that's what basophils do. Endorphins, oh, sorry, not endorphins. Heparin Heparin stops the blood from clotting like very, very quickly. So the platelets without heparin would would um would pretty much just clot way too fast. And so no, not pepperines. Um heparin. So the heparin, what? Go on.
Why does your blood clot in the first place?
So if you don't want your blood to leave your body, you have to stop the wound from staying open. And so like if you can't clot your blood, then you bleed to death because from any cut because you can't close the wound. And so clots are like the preemptive solution to making sure your nothing escapes your body. And so that's pretty much what clots are. So it allows your body to trap everything inside the body and then make sure that nothing else gets in. Any other questions? No, no more questions. Um, then if there aren't any other questions about the immune system, then we're pretty much done. Does everybody have at least decent notes? It's good to hear, Ethan. So boogers they're like they trap all of the let's like the dust particles, the different viruses and bacteria that get into your nose. So if you have let's say um like a leukemia, well not sorry, not leukemia, that's cancer. Let's say you have like a strep cell that a strep virus cell that strep bacteria that got into your nose. Uh sorry, the epithelial cell will detect that and then it'll produce the cement or like the snot, and then that snot traps. So they are all over our body, but boogers are specifically in your nose. In other places like your stomach, it's just a slimy secretion that traps viruses so that like macrophages can swallow them. So boogers specifically, they're just the concrete that's specific to your nose. Good question. Are there any others? That's not everything about immune systems, but it is the most basic. As oh, blood. Why is blood red? So that is due to hemoglobin. This is very off topic, but I will allow it. The reason, so the circulatory? No, this is not about the circulatory system. So, but I will answer why blood is red. So that is because of hemoglobin in your blood cells, and it's just hemoglobin because it traps a lot of iron, and also just the way it is shaped, it gives off like a red color. Sure. If there are no more questions, then I guess class is dismissed.